This is day 18 video for Wednesday, April 22nd. We're going to continue to solve trigonometric equations, but now we're going to have the three different possibilities of how to give the answer. And the first one is going to be principal values. The second one, which the ones we've been doing, is on a given interval. And the third is on the most general form. All right, so now what are the principal values? Well, so far on a given interval, we've had one, usually two solutions for the trigonometric equations. Well, sometimes four, but that's two separate factors. The principal values stem from the fact that we're dealing with functions. And if we just take the sine function, for example, the sine function starts at 0, goes up to 1 at pi over 2, back down to 0 at pi, down to -1 at 3 pi over 2, and back up to 0 at 2 pi. And that's one interval. So this would be pi over 2, pi, 3 pi over 2, and then finishing up over here at 2 pi. But that's only one interval. Remember, this function goes on forever in both directions. What if we were to graph the inverse of this? Well, the inverse of this would be the reflection over the y equals x line with 45 degrees. Or it would come up, and now I'm coming up with pi over 2, 2 pi, pi, 3 pi over 2, and 2 pi. So it would look like that. And that would be one full cycle. This being pi over 2, pi, 3 pi over 2, and 2 pi up here. But remember, this thing goes on in both directions. That is not a function because it doesn't pass the vertical line test. Well, we want f of x, the inverse sign, to be a function, so we have to limit, and we're going to limit it from pi over 2 to negative pi over 2. And that will give us every value of the sine function from +1 to 0 down to over to -1. So those are all the possibilities there. So this is the limitation that gives us the principal values. So the principal values for the inverse sine of x and the tangent, or rather inverse tangent of x, is going to be from negative pi over 2 inclusive to positive pi over 2. So we can get negative answers. Remember, the interval we were doing, we were always going from 0 to 2 pi, so we never would take a negative answer. We'd have to convert it to the positive answer. This will make sense, I think, when I do the examples. The cosine, or rather inverse cosine of x, is going to be on the interval from pi just really, let's make that not pi there on that side. Let's make that 0. That makes a little more sense, to pi. So basically these two are in the first and fourth quadrant, and the cosine will be in the first and second quadrant. And it just has to do with how we limit the function to make it a function, rather the inverse of the trig functions to make it a function. The given interval, we've done all that. The most general form is where I'm going to have to take in the infinitely many answers that just keep going up. And I'm going to have to, just like I did with the domain of the secant and cosecant and cotangent and tangent, we're going to add a 2 pi over a 2 pi plus n, or we're going to add a pi, so I say plus n times n, 2 pi n, or add a pi n, where n is an integer. And I think it'll make a little more sense when I do the examples. Okay, I'm going to solve this equation, the sine of 2x plus the sine of x equals 0. I'm going to do it for the principal values. I'm also going to do it, wow, I can't spell. All right, let's erase. I'm going to do it for the principal values. I'm going to do it for the interval that we've been doing before. So we're going to do it from 0 to 2 pi. And we're going to do it in general form. I might not put it over here. I might put it underneath to see what we get. Okay, first thing, I got a 2x and an x. I can't solve that equation because these are different. They're not the same variable. As soon as you see this, think double angle identity. So that's going to be 2 sine x, cosine x, and now plus sine x. So now everything is just x. I don't have a 2x to deal with. And I have a common factor with sine of x. I'm going to factor that out. Now we're going to set each factor equal to 0. So the sine of x is equal to 0, and 2 cosine x plus 1 is equal to 0. So that's going to give me the cosine of x is equal to, subtract the 1, divide by 2, negative 1/2. So x is equal to the inverse sine. I forgot my equal sign there. So x is equal to the inverse sine of 0. And x is equal to the inverse cosine of negative 1/2. Okay, so the first thing I'm going to think about is the inverse sine. The inverse sine only exists in the first and fourth quadrant. So my answer will be either from 0 to positive pi over 2, or from negative pi over 2 to 0. So it can have a negative answer. This one, in fact, does not. The only answer is right here. So x is equal to 0. So the principal values, x equals 0. There is another one over here. I don't care about that one because it's outside of the range for the principal values. X equals the cosine or inverse cosine of negative 1/2. The inverse cosine only lives in the first and second quadrant. X is negative over here in the second quadrant with a reference angle of pi over 3. So x is equal to, that would be 1 pi over 3 short of 3 pi over 3, or 2 pi over 3. Now I know I have another one down here in the third quadrant, but that's not in the principal values. So my only answer for the principal values is x is equal to 0 and x is equal to 2 pi over 3. And that's it. Okay, now on the interval, the one that we've been doing, so if I look at this one, I know that I have another point over here, negative 1, 0 at pi. So is 0 an answer for the interval? Well, no, because 0 is not included. I only want to go from 0 non-inclusive to 2 pi, so x is equal to pi would be the first one I get to, and x is equal to 2 pi. So you can see the difference in these answers. And for this guy over here, well, yeah, 2 pi over 3 is inside that interval, so x equals 2 pi over 3. And the other one is going to occur down here in the third quadrant because the cosine is still negative here, and the reference angle pi over 3. So I get 3 pi over 3 plus 1 more pi over 3. So x is equal to 4 pi over 3. So these are the 4 solutions that I would get on the interval from 0 to 2 pi. The general form, I'll go ahead and put it down here. The general form says I want to an expression that gives me every possible answer from negative infinity to positive infinity. So there's going to be one of two ways this is going to come. The two answers are going to be directly across from each other, just creating a straight line. Therefore, if I go from 0, add pi, I get to pi, add another pi, I get to 2 pi, add another pi, I get to 3 pi, add another pi, I get to 4 pi, that's going to pick up all the answers. So I don't need both of these answers. I just need a single one. And you can start at 0, it doesn't matter. You don't have to go to the principal value. That is the principal value. Start at 0 plus, and I'm just going to add pi n, of course, where n is an integer. All right, moving across to this one, this is the other way. I don't create a straight line with my two solutions. So I can't add pi. If I added pi to this, that's not a solution. So I've got to go ahead and add 2 pi. But that doesn't pick this guy up. So we're going to have to write two expressions, one for each. So x is equal to 2 pi over 3 plus 2 pi n, of course, where n is an integer. And I also have to write one for x equals 4 pi over 3 plus 2 pi n. So we're just going to practice our equations, and I'll put it in the instructions in the homework, but I want you to write the principal values, the interval from 0 to 2 pi, not including 0, and the general solution for each and every one of the problems. I'm not going to overwork you with them. I'm just going to do 3 of them. It's just practicing basically these. You should be getting pretty good at the solving the equations by now. Keep asking me questions. I'll put up a solutions video probably later today. And yep, have a good day.